So we have a car of mass 1500 kg being towed along a straight road so that its velocity changes uniformly from an initial value of 20 meter per second to a final value of 30 meter per second in a distance of 100 meter. During this time, the friction is constant and equal to 500 newtons. Calculate the accelerations of the car, the magnitude of the net force being exerted on the car during this 100 meter. So I want to calculate the net force acting. The net force here refers to the summation of forces for the whole system, and the towing force. So I represent the towing force with F towing. So try to visualize the forces that are acting on the car. So the car is being towing forward with F towing, and then there is the frictions acting backwards, whereby this frictions is given by the questions 500 newtons. So for the first question, in order to calculate the accelerations of the car, we might apply kinematics equations because the car is moving in linear motions. So I'm going to use kinematic equations. You can refer to the list of formula. So I have initial velocity, final velocity, the distance traveled. I want to find for acceleration. So I might use v squared equal to u squared plus 2as. So my final velocity of the car is 30. The initial velocity of the car is 20. Then the accelerations we want to calculate. The distance covered for these changes of velocity is 100 meter. So do the calculation and solve it. I will get the accelerations will be 2.5 meter per second squared. Then for the second question, I want to determine the magnitude of the net force being exerted on the car during this 100 meter. So we understood that when there is an acceleration means there will be a net force acting on the object. So we can apply Newton's second law, summation of forces equal to ma. So I will take the mass of the car 1500 multiplied with the accelerations 2.5. Then I'll get the net force acting on the car will be 3750 Newton. Okay. Question 3, I want to find for the towing force. So if we refer to the questions, we will find out that the towing force will drag the car forwards. So from question 2, we already get the net force that acting on the car. So actually the net force for the whole system will be the F towing minus the friction force. So the net force is 3750 Newton. F towing we want to calculate, and the friction acting is 500. So I'll get my F towing will be 4250 Newton.